So here is the map we would be trying our robot to navigate through, and these are some of the rules we would be following throughout this course to make our robot navigate through this map. Now, it definitely has to follow the line. It should always turn left in case there is a decision to turn left or right. There are no timing constraints for us. In some of the competitions, there are timing constraints, and performance is a parameter of the time taken by each robot. But for this, we are not assuming any time constraint, and there are always bonus points for efficient design. Now, let us take an ideal scenario. Let us think of an ideal scenario. Here, our board start from here. It should follow this line, and now in this case, it can go both to the left. It can go both here to the left side and here to the right side, but it should always turn to the left side. It should be able to cover angles greater than 180 degree, and to make turns from angles less than 90 degree. In case of this T-type turn, it should turn to the left, take a U-turn here, just go straight through here, and should be able to reach this endpoint. Now, there are always some constraints given by the event organizer or the let's say your project. You have always have some project let's call them project constraints, and we are assuming these constraints. You might not always be turned left. You might be given the condition that sometimes you can turn right, or you should always turn right. There might also be, like I said before, some timing constraints, and there are, I think, always some bonus points for efficient design. So now let us talk about the strategy, the logic we would be using to navigate our robot through this path. Now, some of the people prefer to use two sensors for line detection, and some prefer three sensors or even more to use to detect the line and navigate the robot. But I don't think that it's necessary to use more than one sensors. You can get this done with just one sensor. So how we are making our robot turn left from this direction? The key is simple. Let's say our robot is standing here, right? And it detects, and here is the sensor. It detects that there is a line. In case of a line, it would turn to the left, to its left. So it would be and it would be continuously detecting that either there is a line or not. In the event when it reaches here, where there is no line, it would start turning right. So this would make it come here. Now here, when it detects the line, it would start turning to its left. So it would be moving in a zigzag direction like this. Now see it would be able to make a left turn, right? Because it's looking at the left border of this line, right? So it would be able to take this turn, and in this case, since it turns here, there is no line, it turns more toward its right, and then it start following this, and same thing happen here. It would be able to turn here, and here it would be able to make a U-turn without even thinking about it twice. That's if it's thinking, it's just following this logic. So it would be able to reach this end using this logic. So here is let me tell you the logic again. So let's assume this is the line, right? And let's say here is the way. Now if Now if there is a line, right, it would turn to its left. Yes, and it would, let's say, reach here in 2 or 3 turns, and then if there is no line, it would turn to its right. So this is the logic we would be following.